After showing you tickle and O-tickle, I can now show you how to write a simulation in NS2. First, let me describe in general how a simulation works. NS2 is a discrete event simulator. So a discrete event simulator maintains a queue of events. So these are the events, and the events are sorted by the time it should occur. So each event is associated with a time. The simulator basically is an infinite loop that at each loop takes in an event, execute the event, and move on to the next event, takes the event from the queue, execute the next event, and so on. When an event is executed, it might create more events which cause the events to be inserted into the event queue. Remember, the events are sorted in the time where the event should occur, and therefore populating the event queue. So this is the basic idea behind the simulator. NS2 basically implements such a discrete event simulator plus many other classes that implements various network protocols and related algorithms. Let me now talk about the basic architecture of NS2. NS2 is implemented in O-tickle and C++. So a class in NS2 can be implemented entirely in C++, or it can be implemented entirely in O-tickle. Classes that are implemented in C++ typically implement the low-level functionalities. For example, TCP, in which case you need to process every packet that is coming in and send more packets onto the network. So we need to implement this in C++ for performance reasons. On the other hand, the O-tickle classes provide the flexibility of gluing together different objects in the O-tickle world. O-tickle also provides hooks to configure the parameters in the C++ objects. If you want to simulate using only the existing classes, the existing protocols for example, then most likely you will only need to implement or write your simulation in using O-tickle. On the other hand, if you want to implement your own protocol or modify the existing protocol, you would then have to go down to the C++ level and change or add a new protocol. With this background, I can now show you how to write a simulator in NS2. So I'm going to write my simulator in a file called a.tickle. The first thing in writing a simulation script is to create a simulator object. So let me do that. Let me create a new simulator object and assign it to the variable s. So the simulator object is what I have just described. It basically contains a main loop and it maintains a queue of events sorted by time, and when we run the simulation, it will go through each event in the event queue and execute them. To invoke the infinite loop, or to invoke the simulation loop, we need to call the function run. So what I have just written here is I have just created the simulator and I just run the simulation. So this is a very basic simulation script. So let me now run the script for you. I call bin/ns, which is where my NS binary file is located, and I pass in the file name of the script that I have just written. Here we didn't see any output, and this is because in my simulation script I just set up the simulator. I did not set up any event. So let me now create some event. So I can create event in two ways. One is to use a function called add. So I can say at a particular time, at time 0, I want to, let's say, print out this string onto the screen, and at time 10 I want to exit from the simulator. So now if I run this script, I'm going to see start being printed at time 0 and the simulation exits at time 10. So add is the first way we can create an event and put it into the event queue. The other method to create an event is after. So let me now show you an example of how this way of creating an event can be used. To do that, I'm going to create a function called p, which takes in a parameter x, and within this function what I'm going to do is to print out the current time and the value of x. After this, I'm going to schedule another event in the simulation. I'm going to schedule this 1 unit time after the function p is called, and I'm going to say after 1 unit time let's call p again, but at this time let pass in let's say 2 times the value of x. Okay, so now I have my function p which called itself after 1 unit time, and let me now say run this function p with the argument of 1 at time 0. And let me exit from my simulation at time 30. We are almost done here. There's one minor detail, which is that I cannot access the variable s from within the procedure p. To access s, I must declare s as a global variable, and I need to do the same thing here. So basically what I did is I just made s a global variable, and that should do it. Let's try and run and see what happens. Okay, so as expected, we see p getting run from time 0 to time 30, or time 29 because at time 30 we exit. And here are the different value of x that has been passed in. As expected is doubled every time we call the function. And this is how after is used. So I have just illustrated to you some basic functionality of the simulator class. So basically you can use add and after to schedule an event. You can run the simulator and you can use now to get the current time in the simulator. But being a network simulator, we need to be able to create nodes, run some protocols, send some packets, etc. And now I'm going to show you how to do this. Now I'm going to first create some nodes. So let me use the function node from the simulator to create a node. I'm going to create a source node and a destination node. And I'm going to link them together. I'm going to say duplex link source to destination. Right, so the command duplex link means that the link between source and destination is a two-way link. So you can send packet from source to destination and destination to source. So I call duplex link, pass in source and destination, and now I'm going to configure this link with a let's say 1 megabit per second bandwidth, a 100 millisecond delay, and I'm going to use drop tail queue management protocol on this link. Okay, so I have just created two nodes and joined them up with a link. So let me run this again. We don't see anything because at this point in time I have just created two nodes and linked them together, but I am not sending any packet yet. Now to send packets, we must create a connection between the source and destination node. So to create a connection, I call the function create connection, and I pass in the name of the protocol that I want to run on the source. In this case, let me run TCP/Reno. Pass in the source, and at the destination, I'm just going to run what is called a TCP sync. So this is just basically this is just a receiver for TCP packets. Okay, so after this I'm going to pass in an integer 0. Let's not care about what 0 means for now. So I created a TCP connection between the source and destination. Now let's create some application. So I'm going to attach a source to, well, a packet source to the variable source src. To do that, I'm going to say let me first store the objects returned by this function create connection in a variable. Let me call it TCP. Okay, so this is a TCP connection. Now with this TCP connection, I can attach a source. Right, so this is where packets are generated. So I'm going to attach an FTP source to TCP. Okay, and I'm going to ask the simulator to start running at time 0, and at time 0 I want my FTP to start. Oh, I need to store this FTP source in a variable called FTP. Okay, so at time 0 I call $FTP start, and let me stop at say time 10. I'm just going to exit for now. Okay, so now I have two nodes joined by a link. I have TCP connection between the two nodes, and I have an FTP source at the source. So I can run the script, but again I'm not seeing anything. Even though packets are flowing, we are not printing out anything on the screen. So that's why you don't see anything interesting yet. Okay. NS2 comes with a facility to log packets and log all packets into a file. So let's do that. So first of all, I'm going to create two files. First one I'm going to call num trace. So this is a trace file that is related to num, the network animator. Okay. So I'm going to create a file called a.num. I open the file called a.num for writing, and I'm going to open the file called a.trace for writing, and let me tell the simulator to trace everything and put it into the file all trace. I'm going to ask the simulator to trace everything that is related to animation and put it in the file called numTrace. Now when I exit from the simulation, I now have to do some cleanup. So let me define a function called finish, and what finish does is it close the file numTrace, close the file all trace, and then exit. Before that, I need to remind the simulator to flush all the trace to disk. Okay. And just like before, I need s numTrace and all trace to be a global variable. Okay, I think we are done with this script, so let me now run the simulator. So exactly the same thing happens as before, but now what we get is we get two files, a file called a.trace that has a log of all the packets. It tells you at what time which packet is going from where to where, and what is the size of the packet, what is the type of the packet, etc. So this is a detailed trace of all the packets in the simulation. The other file called a.num also contains all the traces, but it is formatted as an input to another program called num. So num is basically a network animation tool which you have seen before in class. So if I pass the file that I've just created to the program called num, this is what you get, and we can now animate our simulation. So just now we created two nodes, a source and a node. We have a link. As you can see, if you remember, we set the link bandwidth to 1 megabit per second and with a delay of 100 milliseconds. And now if I start playing, you can see packets moving from the source to destination. So now we have a program, a simulation script that create two nodes and a link and send packets between them. I'm going to make this a little bit more complicated now. I'm going to create a third node, let me call it router, and I'm going to link the source to the router and link the router to the destination. I'm going to change the bandwidth of the link from the source to the router to be 2. I'm going to show you now, instead of using drop tail, I'm going to use red. And the next thing I'm going to do is I'm going to limit the size of the queue from router to the destination to be let's say 30 packets. Okay. So now I'm going to show you how we can configure the various parameters of red. Now red is implemented in a class called queue/red, and I can use queue/red to access the various members of the class. So for example, I can set the minimum threshold of red. I can set the maximum threshold of red. Let's say I set it to 10. I can set the weight factor, so say 0.002. I can also set the maximum dropping probability. Now the maximum probability is defined using a variable called lin term or linear term. The maximum probability of dropping is equal to 1 over lin term. So in this case it's 1 over 50, which is 0.02. Sorry about that. Let's see what else we can set in queue/red. I can set bytes to false, meaning that I want the red algorithm to operate in byte mode. I can set set bit to false. Set bit is a variable that says whether red should drop packets or just mark the packets. In this case I set it to false, which means that red will drop packets. There's another configuration variable called queue in bytes, which determine whether the queue size is it in bytes or is it in number of packets. What else? Okay. There's another variable called drop tail. So drop tail determine what would red do when the average queue size exceeds the maximum threshold. Like remember what happened in red. When the average queue size exceeds the maximum threshold, packets will always be dropped. So drop tail will determine whether the packets at the end of the queue will be dropped, or is it that random packets from within the queue that will be dropped. Right, so this defines the behavior of red when the average queue length exceeds the maximum threshold. Okay, so enough parameter settings for red. So what we have done is we created 3 nodes. Let me run this. I created 3 nodes with a queue implementing red, and this is what we have. if you notice, you will see that uh, there should be a queue in the router that is not being shown in the animation. Right. This is because we haven't included any trace of the queue. So let me now add in a trace for the packets in the queue. So what I'm going to do first is I'm going to retrieve the link between the source and the router. Or actually, let me do it from the router to the destination. I'm going to retrieve the queue object in this link, and I'm going to open the file. Let me call it queue trace. Let me call it a.q. I open it for writing, and now I'm going to ask the queue object to trace two variables. The first variable is the current queue length, and the next variable is the average queue length as computed by red. Okay, and I'm going to ask the queue object to trace these two variables and store the results into the file that I have just created. Now the name of these two variables looks weird because they are internal variables in the queue object. Okay, now if I run my script in NS, I should see a file called a.q, and inside this file you will see some information about what is the length of the queue. Right, when the line starts with the character capital Q, this tells you the current queue size, and the lines that start with A tells you the average queue size as calculated by red. Okay, and these numbers here, the numbers in the second column is basically the time, the simulation time. So the way to read it is that simulation time 1.7856, the queue has 5 packets. Okay. We have seen how to create nodes, send packets, and monitor the queue in NS2. The last video was ended abruptly, so I'm going to repeat some of the stuff that I said but wasn't recorded properly in this video. Okay. Okay. So we have seen how to trace a queue. Okay. So now I'm going to show you how we can calculate the average delay experienced by the packets in the flow from the source to destination. In order to calculate the delay or the average delay, we need an object called a flow monitor. So let me declare a global variable called flow monitor. I initialize it by asking the simulator object to create a flow monitor, make flow mon, and I'm attaching this flow monitor to the link. Now recall that the link refers to the link between the router and the destination. So this flow monitor will monitor the flow flowing through the link from source to destination. When I'm done with my simulation, when the simulation is finished, I am going to access the statistics that has been collected by this flow monitor, and this is how I did it. So from the flow monitor, I access a classifier object, right, and assign it to a variable called classifier. From the classifier, I do a lookup. Now, let's not care about what this parameter means, but the important parameter is the last integer here. Right, this is 0. Now this refers to the flow ID. Now this number should correspond to the number here when we create our connection. So when we create a connection, we basically assign a flow ID to the packets that flows from the source to the destination. So when we want to access the flow, we ask the classifier to look up for the flow with the same flow ID 0 that we had previously. So now we have the flow object, and this flow object stores the sample values of the delay of the packets. So I call the function get delay samples. This returns me an object that stores all the delay samples, and I call a method called min, which returns me the mean value of the delay sample. After I do this, I'll just print out the mean. So let me run this script and shows you. Oops. Okay, I have changed something. Before this, I should change this back to red, and now it should work. Okay, so as you can see, when I run, the script is going to print out a number which corresponds to the average delay experienced by the packets flowing from the source. Okay, so this concludes the introduction to NS2. You can find more tutorials at NS2 online. Just Google for NS2 tutorial, and you will see plenty of presentations, slides, documents, exercises on how to use NS2.